Welcome back to Apes. I'm going to just show you what the current responses are for what you all want. Hopefully this is the right screen. So as you can see, there's a lot of requests for energy, as well as a little bit about weather, as well as what you know in the AP exam, as well as Jeff keeps killing houseplants. You're probably overwatering them or not giving them enough light, or both, Jeff. But that won't be on the AP exam. But every time you kill a plant, you've learned something. So it sounds like you're learning a lot this year. Milo, we will talk a little bit about solutions at the end of the week. As far as stuff on the final, there is not going to be a final in the class because the district told me I get to decide whether or not I feel you need a final, and I don't think you do. So with that being said, that gives some of you about 2 weeks of late work window to make up stuff. And by the way, for those of you graduating, congratulations. But now let's go on to the actual learning. We're going to focus on energy today. Here we are. And I've learned not to use the webcam at the same time because it takes forever to upload right now. So this comes right from the energy unit, and we're just going to go over this freakishly fast. Main thing to know is most energy is produced with generators and turbines. The turbine is the spinny part that is connected either to a wind turbine or, in the case of steam generation, part of the boiler system. Or in a hydroelectric dam, this is through the floodgate of the dam. It's connected to a generator. So the key for this, if they ever ask about energy production, you have to have some sort of motion, rotate a turbine. Don't say push or move a turbine, because you could take a turbine, push it across the street, you haven't generated electricity. So you have to rotate a turbine that's connected to a generator that generates electricity. Those are the three things we're looking for. Rotate turbine, drives, powers generator, produces electricity. If you want to do an easier thing, just talk about photovoltaic, because they don't expect you to understand that level of physics. So you can just say photovoltaic panels turn sunlight into electricity. There's a cool animation of a generator. A generator is actually just a backwards motor. If you use electricity to spin one of these things, it's a motor. If you spin one of these to produce electricity, it's a generator. So one of the main things I want you to know is the major uses of energy in households. The AP exam does not give a crap about vampire wattage or things like that. First of all, the three biggest uses of energy in the US are industry, buildings, and transportation. Buildings are both commercial and residential. One awesome thing to see is small buildings, one of their biggest energy expenditures, residential if you look, is heating. Big buildings generally become so hot naturally by their size and the number of people in them, as well as often secondary sources of heat production throughout the building. Their biggest source of energy use is lighting. It's a cool thing to know. So as we're talking about energy, pay attention to which of these it's being used for, and think about what are alternatives and ways to conserve energy. So these are currently our major energy sources. And this diagram I almost have to change every year because, in case you haven't been watching the news, oil just plummeted in value, which is on one level is funny. On the other hand, it is terrible for all these families working and tied in with income with the oil industry. One reason why the oil price has plummeted is no one's going anywhere, so the demand for oil has gone down. So these are the major sources of energy. The awesome thing is that little green wedge for other is growing steadily, and that includes solar and wind. So let's go on. This is how we actually use energy in our houses. As you can see, the major energy use is space heating. If you add space cooling, which is your whole HVAC, heat, and air conditioner, over 40% of your energy is from there. Adding water heating, it's even more. All of these other things are all of your other bits of energy use. An important thing to take from this is it's better for the environment to run your dishwasher than to hand wash your dishes, because a dishwasher is more efficient at keeping the water warm. Renewable means it's energy replaced in your lifetime. Perpetual is renewed constantly, like wind and sunlight. Non-renewable takes longer than a human lifetime to renew a resource. Fossil fuels are a result of fossilized plant life and plant matter. And for the fossil fuels that they often talk about, those would be coal, petroleum, and natural gas are all fossil fuels. Coal, petroleum, natural gas. Traditional energy source is often called biomass. It's wood, peat, and dung. These are burning plant matter. Here are peat logs getting harvested in Ireland. One reason why Ireland does a lot of peat log is there's not much timber there, and there's a lot of people. Modern energy sources are coal, petroleum, natural gas, nuclear. Here is a coal miner in West Virginia, and as you can see, he's not wearing a protective respirator. If there's this much coal dust on his skin, it's lining his lungs, and this is one reason why coal miners have a life expectancy in their 40s. Coal has a lot of environmental problems. I gave you that energy review sheet, and some people said, what are some of the good things about coal environmentally? And there really aren't any. It's a big producer of CO2, releases mercury and other heavy metals, releases sulfur, requires catastrophic mining. There's no infinite supply, and it's the biggest source of electricity in the United States, but that's going down because in the past year, it's becoming cheaper to produce electricity with wind and solar. Hang on, my stupid computer froze. So here's some of the other issues with coal. It makes industrial smog, not photochemical smog, but lots of problems. Natural gas is cleaner. There's no sulfur emissions. Mining methods like fracking aren't the best. And this is kind of a mixed thing. We did talk about fracking a lot this year. Fracking does produce natural gas, which is a cleaner energy than coal. The issue with fracking is not that fracking is inherently bad. It is that it's not currently regulated well. Because we have things like a home explode in Firestone, Colorado, because the fracking lines underneath were not properly capped. But also, fracking releases a lot of VOCs in the atmosphere, making photochemical smog worse. It is great, though, for cooking. Now, this is still a better option than coal. One thing with fracking is on the AP exam, it's not that we should really ban fracking. It is talking about ways to regulate it. So we're tracking what chemicals we use as fracking liquids, and we're capturing all the methane released because methane, if it's not captured from fracking, becomes a powerful greenhouse gas. Petroleum also releases CO2. This is mostly used for transportation. Oh, I forgot. Natural gas is mostly used for heat. Coal is used mostly for electricity. Coal, electricity, natural gas, heat, petroleum, transportation. So this does require processing. The problems with petroleum are oil spills, shortage, and it's a source of greenhouse gases. One thing all three of these energy options have that is beneficial economically is they're easier to transport than like solar or wind. We also get all these components out of gasoline or petroleum by boiling point. So as we raise the temperature, different things become a gas, and it's called fractional distillation, meaning separated by boiling point. Nuclear, we have fission and fusion. Fusion is not an option because we don't have any way to stop the reaction and it would kind of blow up the planet. We keep hoping we'll find a solution, but we haven't. Fission is splitting large atoms like uranium and plutonium and releasing energy. We already talked about the dangers. Storage of waste would outlast recorded history, which means we have no way of making a warning label. Reactors can have meltdowns like Chernobyl. Here's a groovy animation of a nuclear power plant. So this is actually the pressurizer. This is the steam generator. So this thing are the radioactive rods. They're generating heat that's bringing this fluid to a high temperature, which then boils the fluid in a second loop that rotates a turbine that drives a generator that produces electricity. The condenser is the thing connected to the cooling towers. The issue with a nuclear power plant is if this pump, or this pump shuts down, the entire plant will explode. And that is one of our dilemmas. So if they explode, it's called a meltdown because it reaches boiling point, and then the rods melt through the base, and it's catastrophic. And when these things have happened in history, the emergency responders who go in will not survive, but they have to do it to save like the nearby 100-mile radius. But the other thing is we have no way of storing of waste. We've been making nuclear waste for almost, we're coming up on a century of producing nuclear waste now. And we've been saying for that whole time, someday science will find a way to deal with it, but we're now 4 or 5 generations into it and we haven't. So one of our big challenges with nuclear power is the waste. It's also not considered renewable because the uranium has to be mined. The other issue is the Price-Anderson Act. It limits how much a nuclear power plant would be held responsible in case of a meltdown. That is a problem because if they don't have to pay for cleanup, there's often less of a fiscal responsibility to maintain safety standards. Taxpayers are expected to cover the rest through this thing called the Price-Anderson Fund, which is a licensing thing. Current amount in the Price-Anderson thing is around $13 billion. Chernobyl, they estimate, cost over $1 trillion, which means we don't have enough money in the US to clean up a nuclear power plant. And also Sarah Palin, who ran for vice president over a decade ago and is a big dummy head, she actually tried to refund the Price-Anderson Fund to restart the US economy, which would mean we would have no way of cleaning up a nuclear reactor mess. So, and if you're talking about nuclear reactors, here's the epic poor choice in world history. Everybody's like, why would Japan put a nuclear power plant right on the ocean on a volcanic series of islands? Here's San Onofre, California. This is halfway between San Diego and LA. It's a nuclear power reactor right on a tectonically active fault line pretty close to the San Andreas Fault. It's in a tsunami-prone region, as well as an area prone to wildfires. Within the fallout of this plant, if it ever did have an accident, is basically about 25% of the US economy for the southern half of California, and there is no way to evacuate people properly. But people go surfing right next to it. You might have actually seen it if you've been watching Animal Kingdom, which is an inappropriate show you shouldn't watch. So there's the location of the San Onofre nuclear power plant. So fusion is not an option. So don't mention fusion because it's talking about like the fairy tales of science that we just don't have. It's important to talk about the alternatives. So let's go through them. Most forms of alternative energy produce alternate current, and it can't be stored. To store energy, you've got to put it in batteries. And a generator produces alternating current. The thing with like a nuclear power plant or a coal power plant or a natural gas power plant, if you need more power, you just burn more stuff. One problem with alternative energy is since we can't store it and the wind stops blowing, people might need stuff. So for example, when the sun sets, homes are probably using more electricity, so we have to find a way to store the energy. But as we're talking about this, when I was your age, I kept hearing all these Eeyore downbeaten people saying renewable energies will never meet our increasing global demands. And then someone showed me this, and I haven't updated the photo because even now, the cutting edge phone from 20 years ago looks super modern. The more we use the technology, the more advanced it becomes, and the cheaper it becomes, and the more powerful and more efficient. And the same it holds true for wind turbines and solar panels. Nice thing about wind power is there's no carbon output. The drawbacks are there's migratory birds, they're noisy, some people say they're unsightly, they're not good in all areas. One other thing they're adding is the blades don't have an infinite life and cannot be recycled, so they have to get landfilled. You can often see little internet memes about like the destructive nature. Now, yes, these have to go in landfill. Just remember, coal mining produces a lot more solid waste than a few wind turbine blades. The important thing is wind turbines are getting more efficient and quieter. If they're noisy, they're wasting energy. The migratory bird threats have been questionable. Even the Audubon Society said that birds have a better odd with wind turbine than mountaintop removal and climate change. A lot of the migratory bird studies were actually sponsored by the American Coal Association too. Farmers and schools are trying to use them to increase revenue for their properties, and they're kind of awesome. To put wind power in perspective, if we put wind turbine farms in the oil fields of North Dakota and Texas, just there at the density which would keep them efficient, based on the wind speeds there, that's enough to power all of North America. And that data just happened in the past 10 years. So wind is becoming a really good energy source. Solar energy, we've got three types: passive solar and active solar. Passive solar is just strategically placing your windows to keep your house warm. Active solar are things like photovoltaic and solar thermal. So passive solar heats a home, solar thermal makes heat, photovoltaic makes electricity, and that's all you need. Passive solar, here is a passive solar. These windows are facing south, and the entire place is heating up naturally in sunlight. To keep them cooler in the summer when you don't want your house heating up, One trick is you make your eaves a little bit longer, so in the summer, the windows are shaded. You can still have a nice view, but it doesn't blast your house with heat. And passive solar comes in a lot of designs. So this would even be considered passive solar. The key is windows facing south here, and then southern hemisphere, you want them facing north with thermal mass, some sort of tile or concrete or like stony material that heats up in the sun and releases the heat at night. Solar thermal are ways of heating water. If you've ever used a solar shower on a camping trip, that is solar thermal. I know a woman who used to do the Iditarod up in Alaska, and she heats her entire outdoor pool in Fairbanks, Alaska, with a series of garden hoses that are woven or wrapped in plastic garbage bags. It heats up the whole thing, and she has a nice warm pool in Fairbanks, Alaska for the entire summer. Photovoltaic, because you haven't taken graduate level physics, all you have to say is sunlight hits the photovoltaic panel and produces electricity. Here are roof shingles, which were developed by Elon Musk, who has horrible names for his children, as we've established, and is a little bit weird. But it's kind of awesome because this almost looks like a normal shingle. Here are some other modern photovoltaic shingles that have been developed by Tesla. Solar thermal towers are kind of a weird one. You might see these if you watch the movie Sahara, which you are not allowed to watch until after you take the AP exam, because last time students watched it before the AP exam, a quarter of the country thought birds got blinded by solar panels. Birds do not get blinded by solar panels. What these things do is, this is a whole series of mirrors, not photovoltaic panels, and it's focusing sunlight on one single point, which obviously heats up, like if you had that creepy moment with a magnifying glass, sunlight and ants as a kid. As this heats up, it's a salt-rich saline solution that has a higher boiling point and heats up all day, and then at night, that superheated solution can be used to boil fresh water, to produce steam, to rotate a turbine, to drive a generator, to make electricity. So this is a way of producing electricity at night using solar power. There's a summary. Hydroelectric, here is Seven Gorges Dam in China, the biggest dam in the world. Hydroelectric, all it is water gets built up behind the dam, goes through technically a penstock. You can just call it the water chute. It rotates a turbine that drives a generator that produces electricity. Environmentally, dams, they probably won't ask you if they're considered sustainable or not. They're not really that environmentally friendly. Behind the dam, you have increased evaporation because the water moves slower and is heating up in the sun. They have a tendency to collapse and cause bigger problems. They're bad for wildlife because fish can't swim through concrete. Neither can the Yangtze River dolphin that has gone extinct since the construction of the Three Gorges Dam. They're bad for wildlife, and over time, the back of them fills in with silt. Once the silt gets up here, that dam is no longer functional and has to get dismantled. Small-scale dams that we used to have along the Poudre River, but we've torn most of them out. This, actually, don't worry about that. That's not considered alternative energy. Tidal is using the surge of the tides to make electricity. Now, tides are technically a current because the water is slushing in and out as a result of the pull of the sun and the moon on the Earth's hydrosphere, the oceans. So tidal is using ocean currents. And just remember, currents flow. And those make these things spin underwater. So on the AP exam, don't ever say energy from tides and waves because they're different things. So if you're talking about tides, you're only talking about currents. If you're talking about waves, you're talking about the water moving up and down. So I should probably don't say tides and waves, because in past years, if you say them both interchangeably, you start talking about one energy formation and then you switch to waves by accident. Because they're not the same thing, you won't get any of the points. So in the case of tides, the Hudson River fluctuates by 15 feet a day. New York City is not a good location for wind or solar, but it would be a great place for tide energy. In France, off the coast of Brittany, the tides race in close to a mile daily. The Gulf Stream, which is an ocean current, which is still water flowing, It's incredibly powerful. We're not really too interested in channeling energy from the Gulf Stream because if we slow it down, we could put Europe in a permanent winter. So those are all getting energy from, ocean currents, which would be tides, as are these. Waves, there are little float generator switches because waves are water just going up and down, and those also can generate electricity. They're newer technology. We'll talk about OTEC in a second as well. Geothermal energy is using the energy underneath the ground to heat your water and heat your home. So when you're seeing these things, or like solar thermal, it's heating up a liquid in tubes. In the old days, you couldn't have your house there, you had to bury all of them. Now well diggers can actually retroactively drill these into the house. The key is you have to have a yard to do this. So there's more geothermal. Only the green spots in this map are not good sites for geothermal either because the ground is too solid with too much bedrock or it's not warm enough. My buddies Matt and John built their home up here and they made it geothermal, and I thought they were fools. They proved me wrong. In that area, it gets their house up to about 55 degrees. And I was like, you guys are fools, because but then they just used a small amount of propane to raise it up to a comfortable temperature. And then they explained it's a lot cheaper to heat your house from 55 to say 65 than it is to, in northern Minnesota, heat your house from -30 to 65. So they were completely right, and I was mistaken. Biomass is burning plant matter. One issue with this is it does make particulates and air quality issues. The other thing is if you've ever heated your home or know someone who heats your home with wood pellets or a fireplace, it's really hard for them to go on vacation without draining the pipes. OTEC, like we talked about, this is when a bunch of students in Hawaii a few years ago on the APES exam educated every AP teacher and grader in the country because they all of a sudden, this whole cluster of tests from Hawaii started talking about ocean thermal energy conversion, or OTEC. What it is if you're near deep oceans, if you have warm surface water and cold deep water, which Hawaii does have because they're right tiny islands in the middle of a deep ocean, what you can actually do is that warm water can boil something with a lower surface temperature, which is usually ammonia. The cooler water will turn it back into a liquid. So you have a temperature difference and the ability to, if you use ammonia, turn the ammonia into ammonia gas, which would rotate a turbine that drives a generator that produces electricity. Most people who teach AP mineral science had no idea about this technology, but a smattering of students from Hawaii all mentioned it. We looked it up, and now you have to know about it because it's a really cool energy option. You can look up OTEC YouTube videos as well. Solar hydrogen is using photovoltaic electricity to split the water molecule, a process called hydrolysis, and then they collect the hydrogen. The cool thing about that is when you burn the hydrogen, you produce water. But it's a cool way to store energy for things like transportation alternatives. So that could be a possibility someday. So fuel cells are just burning hydrogen to make water. Now, cogeneration is trying to find ways to combine a waste product from one part of your home's energy to benefit something else. So cogeneration is using waste heat from energy production to do other things like heat homes or heat water. Some cities are going incredibly sustainable, like their power plants are using the superheated water that normally would go to cooling towers or cooling ponds. They're using it for things to like heat nearby apartments, or in some cases, melt the snow underneath highways on public roads. Sterling engine, they're not going to ask about that. That's stupid. Decentralizing power is one thing. As we go to renewable energy, we are decentralizing the power. And that does mean eventually the country and the world will have to reevaluate how they are paying for infrastructure like utility lines. Right now, our utility lines are paid for and maintained by utility companies. But as we do things like put on photovoltaic panels and wind turbines, the utility company often still has to provide the lines to that, but they're not getting anyone paying for that energy. Instead, that homeowner is producing more energy than they use, which they then sell back to the utility company. So in the long run, you will probably see the US will have to revisit how we support utility lines. But decentralizing power, meaning not having just one single power station for an entire area, is great because the farther you're going in this grid from the main power source, the more energy you're wasting. For those of you at Poudre High School, if you've gone to the north side of the building, when you hear those high voltage power lines sizzling, that means they're wasting energy. The other reason why this is good is a few decades ago, one stupid squirrel touched two different wires in upstate New York at the same time, and they basically caused a surge in one transformer in one part of upstate New York that shut down the energy grid for most of the Northeast for a few weeks. Other things to look at are improving energy efficiency or using less energy. So remember, this is general heating and cooling. So one of the best things you can do to home is improve energy efficiency. So great forms of energy efficiency in some climates are putting in skylights as long as they open and as long as you don't get heavy snow or you have trees overhead in the winter. But in the case of the US, like here's the thermal picture of a house. Wherever you see red, they're wasting heat. That means the heat's leaking through. Those are single pane windows, and some yahoos decided to vault the ceiling in their master bedroom, forgetting that they needed to insulate afterwards. Ways that you can improve insulation are just making your walls thicker if you're building new construction. When we built our house, we built it out of 2x6s. Our rental right now has walls that are 8-inch thick of concrete, and it is incredibly cozy. Here's a house built out of straw bales, and then they get covered with concrete stucco, both on the inside and outside. This doesn't look like it's that strong, but if you've ever had to move bales or hay bales and straw bales, you know these things are heavy and dense as heck. This is actually stronger than a house built out of 2x4s. Also finding ways to improve your insulation, adding more panels of glass to your windows if you replace them. Here, and for those of you when you go to rent places, a good time to figure out your next rental is in the winter. Look at the roof of the place after a snowstorm. Here you can see they had put in recessed lights over the bathtub, and they forgot to insulate above it. Another sign that this house has bad insulation is if you look, you can see the 2x4s that are supporting the roof right there. That's another sign this house is not well insulated. Also means if you, another sign of bad insulation is this 5 inches of gray you see right there is an ice dam, which means that house is getting water damage and the shingles are rotting. In the immediate presence, like this would not be a comfortable bathtub to soak in because ice cold air is just plummeting right through this roof directly on you while you're trying to soak in your bathtub. Finding better insulation is huge. Things you can do are fiberglass, blown-in insulation, foam insulation, hay bale, things like that. When you buy a house, they often tell you it's insulated, and you often can't tell until it's too late. But you can do things like get an infrared thermometer and just beam it on different walls and windows if you're touring a house in the winter, just to see what kind of surfaces you're dealing with. Roof insulation is another thing. If you don't know what you're doing, have a professional do your roof insulation, because if you do it wrong, it traps moisture in your house. Windows, old windows, like our old house, had a single pane of glass. Our new windows have double panes of glass. When I worked at the boarding school in northern Wisconsin, we had triple panes of glass because it got down to -35. The key is what these windows are doing with multiple panes is there's an airspace. Glass conducts heat. Air does not conduct heat as well. So if they make air spaces, and they usually go for argon because it doesn't really conduct heat at all or as much. Krypton is another gas they like to use, not related to Superman. It's a noble gas. I'm sorry. But these little air gaps help make the windows warmer. Another thing you can do if you are renting a place and it doesn't have good insulation, something as simple as putting on blinds or thicker curtains that you keep closed at night will keep your home a little warmer and save energy. These are some of the worst appliances and for wasting heat. The key for all of these is first of all, you're going through all the steps to produce electricity, and then you're turning it back into heat with a low efficiency appliance. An electric stove works much better than a crock pot or a toaster. Obviously, I don't use a curling iron at all. I do use my electric coffee maker because I like my coffee to start brewing before I wake up. Just know that these things use a lot of energy. Transportation is another place where we can save on energy. So as you can see, we use so much gas in the US that now that everybody's not driving anywhere, the price on gasoline has plummeted. Public transportation is excellent. So are things like railroads, electric cars, carpooling, biking, walking, skiing. Yes, where I grew up, I knew people that would cross country ski to school. All these things are great ways to reduce our energy consumption. Even electric cars, if they're powered by a coal-fired power plant, the carbon that they're generating is the equivalent of a car that would get 115 miles per gallon. So buses don't work as well just because they block traffic. So buses and cars are okay, but light rail, which would be subways, are best, and trolley cars. Light rail just means lightweight train. The best way to move freight is not by trucks, but by trains. And I know those of us who live in Fort Collins, we get so annoyed by the train. The dilemma is the train tracks were there 5 years before the city of Fort Collins was built. They were here first. Another thing we can do is increase fuel efficiency standards, which our current administration is lobbying against, but consumers do tend to prefer this. And that gets into a term they often ask about on the APES exam. CAFE standards stands for Corporate Average Fuel Economy. Federal standards for the longest time through various presidents, including George W. Bush and President Obama and Bill Clinton, we kept nudging up fuel economy standards. The goal was to have cars up to 50 miles per gallon by this year. Detroit auto manufacturers lobbied against it, so did a bunch of politicians in the oil industry. They wanted us to get SUVs. And in case you didn't know, all an SUV is it's a minivan stuck on a truck chassis. The problem with this is in the late 2000s, so the last recession, and this happened. Saudi Arabia, or gas, sorry, wasn't related to Saudi Arabia. Well, I guess it was. Gas skyrocketed in price. It reached $100 per barrel. We're a lot lower than that right now. When that happened, all of a sudden it costs over $130 to refill your Suburban. And immediately, Americans who couldn't afford that kind of gas bill started downsizing to smaller cars. All the cars with better fuel efficiency were not made in the US, so the auto industry had a slump, which led to that chain reaction we talked about, which led to the 2008 recession. Oil ended up getting cheap again because all three of these guys had a mean girls fight. Saudi Arabia found out Russia was meddling in their elections, so to get even and bankrupt the oligarchs, they put too much oil on the market, which ultimately led to cheaper oil prices, but a ripple effect as it laid off people who worked in oil fields in western states, including Colorado, Wyoming, and North Dakota. By the way, a similar thing has happened right now with fewer people buying gas. The same countries flooded the market again with oil, and it's bankrupting everyone. And the ripple effect are people working in the U.S. So that's what happens with oil use. Here's some good news, though. Today, wind turbines can now meet our energy demands, as we already talked about. So there's other awesome, even though Elon Musk is a complete weirdo, other good news is electric cars are becoming incredibly popular. Elon Musk has not put a patent on the battery designs he's generated so that other manufacturers can use them, and also so oil companies and other energy companies can't buy the patent and bury the battery, hide it from the public. Costa Rica is now almost entirely carbon neutral, powering their country for most of the year on renewable energy. Part of it right now is hydroelectric, but their next goal is to phase out hydroelectric for more solar, more geothermal, as well as more wind. The fastest growing job sectors in the US are in wind and solar. Right now, well, sorry for those of you in Illinois, but I'm originally from Wisconsin, so no one cares about Illinois. Illinois figured out they can produce half their power by wind, just so you know. Right now, Fort Collins and Boulder are in a giant fight to see who can go carbon neutral first. And even though you might think that's just two little cities, those two little cities are a huge chunk of the Colorado's economy. It's also a huge population center. So there's your energy review, and hope you enjoyed it. Miss you all. And Mila, I will give you some hints on some of your requests as well. Jeff, stop overwatering your plants.